when you have a division problem and the coefficient is not a 1, that poses a bit of a problem. And we had that same situation when we did completing the square. I don't know if you guys remember that or not. But when we completed the square, if we had something where the coefficient of this was not a 1, I'm kind of translating it funny, but it was a pain in the rump to deal with. This too is a pain in the rump. In order to utilize synthetic division, you first must pull out the coefficient, which is going to look like this. Okay? When I pull that 2 out, the 2 is going to get thrown back in later. But for our purposes, pulling the 2 out allows us now to use the synthetic division process that we learned last week with a very, very ugly number. If you recall, again, that pattern is whatever the x is with a coefficient of 1 minus a positive number. Since it's showing this as a positive, that means 3/2 is negative. And we start by listing all of our coefficients in order of decreasing degree of x, making sure there's no holes. x3, x2, x1, and a constant, no holes. 6 plus 7 plus 1, 1x plus 1. Okay, and we're going to do all the same things that we did before. Bring down and then multiply, which this is where it becomes a pain in the rump because you're multiplying whole numbers by fractions. And some of you can do all this in your head, but just to kind of remind you, 6 times a negative 3/2, cross cancel, you end up with a negative 9 because that's negative. Okay, so negative 9. Add those two items together. You get a positive 2. I mean a negative 2. Gee, crickets. Negative 2. Now multiply by that. Negative 2 over 1. Negative 3/2. Boom, boom. You now have a negative 3. I'm looking at this, or a positive 3. Add together. Multiplying again. Positive 4 over 1 and a negative 3/2. Going to have a negative something. Negative 6. There's your end result. And whatever we start with, the first item in the quotient is to the next degree down. So we started with an x cubed. That means this is going to be x squared. So bear with me. We're about to reintroduce our 2 in a minute. 6x squared minus 2x plus 4 negative 5 over x minus a negative 3/2, so plus 3/2. Okay, but we're not done yet. Our friend, the 2 that came out of this mess, forces us to have to cut everything in here in half. Okay, if we pull out a 3, you'd cut it in thirds. If you pull out a 4, you'd cut it in fourths. Okay, because we pulled that 2 out to correct the quotient and fix this fraction, we have to fix all of this. Only this. Notice I'm kind of ignoring the remainder here. 6 divided by 2 is 3, so that's 3x squared. Negative 2 divided by 2 is negative 1, so that's negative 1x. Positive 4 divided by 2 is positive 2. Okay? That corrected this portion. The remainder number remains the same. Because we put that 2 back in, it corrects this fraction. Goes back to the original form, which was 2x plus 3. Okay, so picture what you have here. If you multiplied this piece by 2 over 1, it would cause it to become that. Okay, can't divide fractions, multiply, you get your answer. Okay, so it's really a process. It's more confusing than anything, but it's a process. If the coefficient is something other than a 1, pull it out. Pulling out that 2 caused this to also be that. 2x plus, if you multiplied it back in, it's 3. Okay, distributing it back in is that version. That's your divisor. Do all of your dividing. The item that you pulled out is used to divide the quotient of the fractional problem. And the item that you pulled out, by dividing it, fixes the quotient back to the original divisor. Okay? I just want to add that this is very clunky. I prefer just normal division when I have a coefficient that is not a 1. You like this? Fantastic. If you don't, that's fine too. I want you to practice it anyway in case you're ever in a place where you need it. Okay? Let's do another sample. Another sample. How about number 13? Are you guys all clear with this, or do you want me to do another sample? Sample? No? Yes, thank you. Sample, here we go. This is what number 13 says. Okay, so the divisor has a number as a coefficient of x that is something other than 1. So I'm going to factor out that coefficient, making my new divisor 2 times x plus 1/2. Okay, I factored out that 2, which makes my new divisor x plus 1/2. So using synthetic division, x minus a positive number, since it's plus, that means the half has to be negative. Negative 1/2 into all of this. Nothing changed here, we just pulled it out of there. So 2 minus, let's make sure it's in order. 3, x2, x1, and a constant. It is 2 minus 3 plus 4 minus 2, step 1, bring it down. Multiply 2 times the divisor. 2 times negative 1/2, negative 1. Add those together. You should have a negative 4. So far, so good? Negative 4 times 1/2. You should have a positive 2. Positive 6. Positive 6 times a negative 1/2. You should have a negative 3. And again, you can work those however you like. Negative 5. The divisor's largest was a 3. So your answer is a 2. The largest degree was a 3. Your answer is a 2. Here we go. 2x squared minus 4x to the first plus 6, and the remainder is negative 5 over this crazy thing. X plus 1/2. To correct the fractional divisor back to the way it was originally, we're going to take everything and cut it. We're going to take everything and cut it in half. Okay? 1/2, cut everything in half. It becomes x squared minus 2x plus 3, because of this, minus 5, and this now, because we cut this in half, this goes back in. 2x, yes sir, plus 1. The original divisor. Okay? Now, the last thing I'll leave you with, as far as these are concerned, know that you don't have to use synthetic division. It's easy for the ones where the coefficient is a 1, but to me, this just adds extra work to my time. I would rather just divide it the normal way. Some people love this method. I like it for when the x value has a coefficient of 1. I do not like it for this. I feel like it's too easy to follow up. People forget to reintroduce or re-include that item that we pulled out. Okay? Okay. I'll give you the rest of this time to go ahead and practice. In your seats quietly.